All right, the last thing I want to talk about today for section 3.2 is solving systems by elimination, which is the third way to go ahead and solve systems. We talked about graphing, we talked about substitution. Elimination is the appropriate time to use that is when you have two equations that are in standard form. All right. Two equations that are in standard form is the best time to use this. So whenever you see like ax plus by equals c, and then you have, dx plus ey equals f. That's the best time to go ahead and use this. Okay. So for this first one, you see you have two equations here in standard form. So what you're going to do is you're going to take and you're going to look to see if you can eliminate either one of the variables. So in this one, by combining my x's together, I have a positive 3x and a minus 3x. So that cancels out, which means I'm just left with my y's here. Okay? So if I have negative 6y and negative 2y, I'm going to go ahead and I'm going to have negative 8y. This right here is a plus 21. So I have plus 21 minus 13 is going to give me 8. All right? Go ahead and divide by negative 8. Divide by negative 8. I get y is equal to negative 1 there. Okay, so y is equal to negative 1. Now, what you're going to do with that is remember, all of my solutions are ordered pairs. I have to solve for an x, and I have to solve for y. So I'm going to take, and I'm going to substitute this all the way back up in here. So now, my second one to solve for x is going to be 3x minus 6 times negative 1 is equal to 21. 3x, a negative times a negative gives you a plus 6. I'm going to subtract 6 there and subtract 6 there, so I get 3x is equal to 15. And when I divide by 3, I get x is equal to 15. Excuse me, x is equal to, let me erase that. X is equal to 5 when you divide, so I'm going to go ahead and say my solution is 5 comma negative 1. Okay? Gets a little bit more difficult. You notice in this next one, number 3 here, you have 10x plus y equals 1, and 10x plus negative 9 equals negative 9. Okay? Neither of these variables cancel out. So what you want to do is you want to take the bottom equation, and if this is a positive 10 right here, we want to make it a negative 10 by multiplying by negative 1. Okay? So my top equation is going to stay the same. 10x plus 1y equals 1. And then I got negative 10x. And what happens is you distribute it here, here, and here. So I'm going to get plus 9y, all right, is equal to a positive 9. All right, this eliminates. So when I go ahead and I draw my line right here, I'm left with 10y is equal to 10. So y is going to equal a positive 1. Go back to your originals, and I'm going to go ahead and put it right here. So I'm going to be left with now 10x plus 1 is equal to 1. And when I subtract 1, I get 10x is equal to 0. When I divide by 10 and divide by 10, I get x is equal to 0. So my solution is going to be 0 comma 1. Okay? Now, sometimes we might run into the situation where it doesn't just eliminate for us right away, and it's not just a negative sign off. Sometimes what happens is we might actually have to take and change both equations, or we have to multiply by an actual integer here, okay? So for this one, look, you got negative 14x and you got negative 7. Those don't cancel. Negative 4y, positive y. Those don't cancel. So what I think I'm going to do for this one is I'm going to take and I'm going to multiply this bottom one by a negative 2. All right, so that I can go ahead and get rid of my x's here. Top equation doesn't change. I have negative 14x minus 4y is equal to negative 10. And my bottom equation now is going to be 14x minus 2y is equal to a negative 26. My x's cancel out. My y's become negative 6y, and I get negative 36 over here. So my y is equal to 6. And then I would go ahead and substitute back in to one of my original equations here. Okay? And that would go ahead and let me solve for x then. Okay. Last example I think I want to do is number 7 here. X's don't cancel out, Y's don't eliminate. So what you have to do is you actually have to go ahead and multiply both equations this time. So let's say I want to get rid of my Y's this time. All right. Well, this one right here, if you want to go ahead and eliminate these, I think the common factor here is 12. So I would multiply the top one by 4, and I'd multiply the bottom one by 3. So my new equations are going to be this. Negative 36x plus 12y is equal to negative 120. And then down here I got negative 6x, all right, minus 12y is equal to a 36. My y's cancel out, and I'm left with, let me draw my line, negative 42x is equal to negative, if I went ahead and took 20 and then 16 out, I got negative 84. When I divide, I get x is equal to a positive 2. And then I take and I substitute back into my original. All right, negative 9 times 2 plus 3y is equal to negative 30. I got negative 18 plus 3y is equal to negative 30. When I add 18, I get 3y is equal to negative 12. So my y is equal to negative 4. Solution, 2 comma negative 4. That, guys, is section 3.2, solving by elimination. Yesterday I went ahead and I did solving by substitution, and the day before that we did graphing. So you now have the 3 appropriate methods that you need to use in order to solve systems of equations.